Testing 1 2 3. Testing 1 2 3. Can you hear me? Okay. Okay. Right.
Before you actually, if you call it to order, something to announce.
Before we call it to order?
No, that's-
But as soon as I call it to order. Okay. All set. The APCD Variance Hearing Board will come to order at 5:30. Before I call the roll, Mr. Herlock wants to say something.
Yes, I wanted to disclose to the petitioner and to the board, as I was going through the draft order, I came across a question which I thought that possibly staff would not be able to answer here at the meeting without some research or consulting with engineering. So I forwarded it to Chris and just wanted to announce that. I'll mention it when I get to that question later.
Okay. Thank you, Mr. Herlock. Clerk, will you call the roll, please?
Board Member Bonsbach?
Here.
Board Member Murphy?
Here.
Board Member Herlock?
Here.
Board Member Carmen? And Board Member Stubblefield.
Here. Okay, would those planning to give testimony tonight please rise to be sworn in?
Okay. Will you please raise your right hand? Do you solemnly affirm that the testimony you are about to give in the matter now pending before this board will be the truth, the whole truth, and nothing but the truth?
Thank you. Okay, we have one item on the agenda tonight before us, petition number 856. This is the petition of Dos Cuadras Offshore Resources, LLC, for an interim variance from Air Pollution Control District Rule 29C, conditions on permits, violation of permit conditions. Would the petitioner like to state your case?
Yes, we do. Yes, we will. Good evening, hearing board members, Ventura County staff, Dan, Chris, and then Eric.
Excuse me. Before each of you speak, if you're going to speak, would you please introduce yourself to the board?
Absolutely.
Sorry.
I was getting there.
Okay.
I was just saying hello to everybody. My name is Christine White. I'm an environmental advisor for DECOR. I have with me tonight Mr. Bob Garcia. He is the Vice President of California Offshore Operations for DECOR. So we've got the management input into this process. And we have Ms. Emily Homan, a facility engineer who's working on the project. So you have both the environmental component, the management component, and the facilities technical component here.
Excuse me, I didn't catch the engineer's name.
Emily Homan, Hohmann.
Thank you.
Thanks. So the DECOR team is here today to explain what happened, what we are doing to fix it, and answer any questions that you may have. As you know, we filed for an interim and a regular variance petition. Can you hear me okay? No, volume's good? Okay. Yeah. We filed for an interim and a regular variance petition due to a failed emission source test on the enclosed ground flare located at DECOR's Mandalay onshore facility. Sometimes we refer to it as MOSF, the Mandalay Onshore Facility. This facility is located just south of the Mandalay power plant that is now operated by NRG. We're a very small footprint just south of them along the coast. This facility, the Mandalay facility, processes oil and gas as well as water that's produced at the offshore platforms, Platform Gina and Platform Gilda, located in OCS waters. So there's two pipelines, a gas and an oil pipeline that comes from Gina, and a gas and oil pipeline and water pipeline that come from Gilda. Should I continue on, or you want to take a break?
Excuse me for being rude and interrupting, but I just want to announce that Mr. Carmen, the fifth member of the board, just arrived.
Okay. All right. Hello, my name's Christine White. I'm an environmental advisor for DECOR. This is Mr. Robert Garcia. He's the vice president of California Offshore Operations for DECOR, and Emily Homan, who is the facility engineer for DECOR. Okay. And we just started a minute ago. I was explaining that we've filed for an interim and both a regular variance petition due to an emission source test of an enclosed ground flare located at DECOR's Mandalay onshore facility. The facility is located just south of the Mandalay power plant. It's now operated by NRG, the big stacks that are along the coast there. The Mandalay facility has a small footprint, but it processes oil and gas that is produced at the offshore platforms, Platform Gina and Platform Gilda, located in OCS waters. So at Mandalay, there's a produced gas treatment system, and that system has an amine plant that is used to remove CO2 and a remaining H2S from gas prior to transferring that gas to the Southern California Gas Company sales line. That transfer occurs at that Mandalay facility. And the amine plant produces something called tail gas. That is the waste gas from that process that has a high CO2 content, and that is sent to the enclosed ground flare to be combusted. So the emission source test that was conducted found NOx emission levels above permitted limits, just slightly above. Our permit limit is 0.06 pounds per MMBTU, and the emission source test came in just over 0.07 pounds per MMBTU, or per heat content. The tail gas that goes to the flare is a direct result from the amount of produced gas that actually goes into the plant. And after we discovered the failed emission source test, we went back to look to see, well, what is causing this? And it turns out that the tail gas rate is a lot lower now due to a lower produced gas production rate. And the way to correct that is to increase the produced gas that's going into that system. That's kind of the short, simple answer. I've got Bob and Emily here. They're going to actually take you through a process flow diagram that's going to explain what it was in the past, what it is currently, and what we're going to do in the future to resolve a process flow bottleneck that actually occurs on platform Gina. Remember, the gas comes in from Gina into Mandalay, and so we have a process flow bottleneck that needs to be resolved by putting in some additional piping around a vessel. Let's see what else we're going to say. So before I do turn it over to Bob and Emily, I thought I would just take a minute to talk about a timeline of what we're proposing to fix this problem. We feel that we'll be able to have the process flow addition piping on Gina installed by July 30th, no later than July 30th, could be sooner. And by August 15th, we can schedule an emission source test on the flare unit, and then the results will be available within 30 days of that, or by September 15th. So we'll be 100% in compliance by then. I'll briefly summarize some of the findings, because I know that you all have to make sure that we meet all of those findings. But first and foremost, we talked about the reason why we're here, because we have an emission source test that showed that we were not in compliance. We'd like to continue operating the flare while these fixes are going on. We also, I'm trying to find my notes here. Basically, we'll be able to monitor the daily gas flows, either the tail gas as well as supplemental fuel to the flare on a daily basis, and we'll be able to report those out by the 10th of the month. And from those, we can summarize excess emissions from this unit. We don't expect a large amount of excess emissions. Let me get my notes here. At the current rate, we're at the limit is 0.06, and we're at just over 0.07. That turns out to be about 0.3 pounds an hour of NOx excess emissions, 0.3 pounds per hour. That turns out to be about a little over 7 pounds per day. And the flare itself is actually all of the annual emissions are at, it's at 1.62 tons per year. That's what that unit is permitted at. And if we're operating for the whole year the way we are right now, we would only be at 1.3 tons per year. So we'd still be below our annual limit. What we're going to be exceeding is our pound per hour limit, pound per day, and probably pound per quarter. This exceedance came as a surprise to us, and there was nothing that we would have known ahead of time to know that we were at that point. There's not going to be any odor or any nuisance complaints by continuing to operate the flare. The flare is operating normally. There's nothing wrong with it. We've got both H2S and other fire everything at the plant to monitor the operations to make sure that it's continuing safely. And we don't expect any public health issues associated with continuing to run the flare the way it is right now. So the last thing I think is an economic issue for DECOR. If we cannot continue to operate this flare, we'd have to shut down our amine, our gas treatment plant at Mandalay. That could affect not only production from a certain well on Gina that we'll talk about it in a minute, but H1, but it could result in the complete shutdown of both Platform Gilda's oil and gas production as well as Platform Gina's oil and gas production. And that comes out to be about, I think it's $137,000 per day of lost income, of lost revenues to DECOR. Platform Gilda is our largest producing facility, and so it would be a significant economic loss for DECOR if we had to shut those down. I'll let Bob and Emily explain more why that would happen, but I just want you to know that this is a big issue for us. So I'll turn it over to Bob right now.
Thank you, Christine. Robert Garcia, Operations Manager for DCOR. And first off, I'd like to just start out by seeing if you've got any questions on what we've already explained to you at this point.
Do any members of the board have any questions at this time?
I have a question, just to understand the issue here a little bit, that you found out there's a problem that you have to use more what you call PUC quality gas than normal, and that raises the amount of nitrous oxides that are produced. Is that because PUC quality gas has more nitrous oxide in it? Because you say it's because of higher temperatures.
That's right, sir. That means that the combustion temperature is higher than what is rated for the NOx values that we're trying to achieve. If we use a higher percentage of PUC gas, it causes the chamber temperature to be higher, which then causes the NOx to form.
Is there a different, if you raise the temperature, is there a different chemical reaction occurring that produces more NOx?
It does relate to creating more NOx in the combustion process at higher temperatures, yes.
Because there's some different chemical reaction that's going on at a higher temperature?
It's basically the end products of combustion.
Yeah.
So now putting in the tail gas actually gives us more CO2. It's an inert gas. It really doesn't burn, but it lowers the chamber temperature, the combustion temperature within the flare, which then prevents the NOx from forming or minimizes it.
Because I'm just, you know, in my mind, and I'm not a chemist or you know, I'm just trying to comprehend these things, that you got nitrous oxide coming into the gas, and then you burn it, and there's more. Does it appear from something?
Well, let me step back a little bit. So the air permit requires us to combust the gas at a temperature of 1,400 degrees or higher. So that's our lower limit. So in order to reach that temperature, you know, tail gas does not burn at all on its own. You need to add supplemental fuel. And in our case, we add about 30 MCF a day. You know, that's like the minimum that you have to add there. 30 MCF a day of supplemental fuel, which is PUC gas. That has to be added to the flare, to the tail gas stream, in order to keep the flare above 1,400 degrees Fahrenheit. All right, so it's not only that the combustion temperature, I mean, that is a factor, but we also have a lower limit as well. So what we found is, in the past, we had tail gas rates to the flare like at 120 to 130 MCFD. This last source test, we were in like the 90s. So we were significantly lower amount of tail gas going to the flare, while you still have to keep 30 MCF going for supplemental fuel just to keep the flare operating and lit at all times. Does that explain it a little bit?
Yeah, I think I'm
Okay.
to the limit of my ability catching on.
I'll let you.
That you said that you couldn't have anticipated this result. I mean, it's only that you, in retrospect, figure out what was going on, and you really wouldn't have been able to foresee this occurring.
That's correct. We didn't know until we actually tested at this lower tail gas production rate that we had a problem. And further investigation led us to understand that because of the lower tail gas volume, created a different chamber temperature scenario, which then causes NOx to be out of compliance. So the only way we can see a fix is to increase production, which would allow us, off of this one well that we're going to discuss, which would allow us to extract more tail gas from that production, and in turn then work our system to be within the spec on the NOx.
Thank you.
I have another question.
Mr. Carmen?
Any more gas that has CO2 into the flare to use for the combustion?
We could, but we are not plumbed that way, if you will. And quite literally, we actually try to extract CO2 from the gas as much as possible, which is part of our process to sell it through the SoCal gas system. So
Nitrogen is about 300 times worse than CO2.
I'm sorry?
Pound for pound, nitrogen oxide is about 300 times worse than CO2 for the environment.
And that's what we want to try to limit. I mean, but
Yeah, but that's why I was saying
that's correct.
we use the CO2 to bring it in. It will be gas CO2, but it will be less harmful than using than the nitrogen.
Right, and the CO2 that we're talking about is produced from our tail gas off the amine plant as a byproduct of producing gas from this one specific well that we're going to discuss. But yes, I agree with you. We need more CO2, and the only way to do that is to increase our tail gas production. It's part of the system that we'll describe here.
Okay.
Do any other members of the board have any questions at this time? Dr. Feinspach?
You mentioned that you're limited by the number of pounds that you can produce per year of NOx emissions. Is that?
Yes, the air permit, For each emission unit, we basically have a limit of what we can produce a year. That's correct.
And you're under that limit?
Well, right now, we're not under the limit for the pound per year. For the tons per year, we are at the current rate, but at the pound per hour, we are not. But the reason why is because our process flow rate into the flare is low right now. We're below our annual limit of the tons per year. You have pounds per day, pounds per hour, then you have pounds per day, and then that rolls up into tons per year. But that's the answer.
Ultimately, what matters is the number of pounds that you're producing. So on an annual basis, you're under your limit.
We are under our limit on our annual basis, yes, at this time, yes.
And will you stay under that limit when you make the changes?
We still will, yes, because when we make the changes, our NOx levels will go down on the pound per hour, and that will counteract the higher rate that we have right now. We'll have a higher flow rate into the flare of tail gas once we make these changes, but as a result of that, we'll have a lower NOx emission output.
Okay, thanks.
Yeah.
Dr. Herlock?
I just wanted to clarify something. I thought that the only violation going on right now is your NO2 per MMBTU. And you said it was pounds per hour, and I thought that was, did I misunderstand that, or did you misspeak?
No, I didn't misspeak. The actual limit is pounds per MMBTU, but you can do the calculations to turn that into a pound per hour. So you can go back and forth between the two. But the actual limit for the emission source test for NOx is 0.06 pounds per MMBTU of heat value. That's the way the permit is written. That's correct. But there's also tables on pound per hour and tons per year as well in the air permit. There's both.
Okay, thank you.
I have a question. I think of NOx as a byproduct of high temperature, like in an automotive engine, high combustion chamber pressure. That's what produces NOx. And in cars, we try to reduce NOx or eliminate it by catalyzing it and using other means. Here, it sounds like you're saying that because throughput has been diminished and it's beyond your control, correct? From Christine or Gail,
Gina.
Excuse me, Gina. So what is it that you're proposing to increase in order to, you say you want to raise the temperature higher, which to my mind would produce more NOx, not less.
Yeah, go ahead.
What we're trying to do is increase the amount of CO2 production, which is a byproduct of one of the wells on platform Gina. And that tail gas is then directed to the flare, which is combined with PUC gas, to lower the chamber temperature within the flare to reduce the amount of NOx. Right. Yeah, sure.
So just to further clarify that, I'm Emily Holman, by the way, I'm sorry. The proportion of PUC quality gas to tail gas at this time is high because we have a minimum for PUC quality gas that we have to.
What is PUC quality gas?
It's our sales gas, so it's sales quality gas.
Public utility.
Public Utility Commission.
So because the proportion is higher at this point, when we increase tail gas going to the enclosed ground flare, that proportion is lowered, and therefore we have lower NOx production. And we're able to combust at a lower temperature.
So, I said this excess nitrogen, you probably have it at least since November of 2014, and it's going to last till maybe September of 2015. So it will be on for about a year.
Well, we're proposing to have all of these piping changes by July 30th at the latest.
Yeah, but you were saying you had to test it and...
Yeah, but by the time the piping changes are made on Gina, then we'll have increased production to the gas treatment plant, which will increase our tail gas to the flare. So that should be all done by when that piping is completed. We won't be able to, prove that we're in compliance, but once that's done and we do the tests, we'll be able to show you.
No, I'm curious because I'm a civil engineer and not a oil engineer, so I like to make things that are tangible to me. And I figure out that decrease of 23% of nitrous oxide that you're doing right now, what is the effect it has in a year? And basically, this is what you're doing is equivalent to having about 77 more cars in the road.
Well, I can tell you exactly. At the current operating rate right now we've got 92 MCFD of tail gas going to the flare, and we've got about 30 MCFD of supplemental fuel. If we keep doing that for 6 months, the excess emissions would be 0.65 tons a year. That would be excess is if we above point, like right now we're at 0.06 pounds per MMTU. Going to 0.07 pounds per MMTU it represents about 0.65 tons a year, half a ton of NOx.
No, right now the one you're permitted is 300. You can burn 300. What 300 cars will use in gasoline.
Okay, I haven't
burning CO2.
I haven't done those calculations, so
Well,
I
I've done
can't
it.
confirm it.
You can get in the internet and find it out, but you can find it there. So you're burning about. You're permitted to burn about 300 cars trafficking in Ventura, and with the excess, you're putting 77 more cars in Ventura. In fuel, because what happened is the cars they burn CO2, but like I told you before, the CO2 is much less harmful than nitrogen oxide, which is 300 times pound for pound more powerful than in the environment than CO2.
Well, let me. I guess maybe everyone doesn't know. This gas treatment system, has an amine plant, and that's what creates the tail gas. We could just put that into the air directly, but our permit doesn't allow us to do that. We have to send it to the flare to combust to make sure that there's no hydrocarbons all hydrocarbons will get combusted. So we pretty much, in order to run the plant, we have to direct it to this flare. There's no way around it. But the excess emissions are 7.16 pounds per day of NOx. So I don't know if that's equivalent to 300 cars or not. I have to take it what you say. I haven't researched that.
Oh, I can show you my calculations once you want later on.
But that's what the excess. It's basically 0.3 pound per hour and 7.16 pound per day. That's where we're at.
Mm-hmm. If I may, our efforts here, I think, to present to you is that we're diligently trying to get this thing corrected, and we recognize the fact that our NOx emission levels are above the permit level, and we want to work as quickly as possible to get it back to that specification so that we can avoid this excess emission. So what we're asking you here is if we can basically get some time from you to allow us to make these corrections so that we can get to that specification.
Dr. Bosbach, I believe you have another question.
So your NOx emissions, the absolute number, will actually go down when you get this excess gas coming in and cool the flare. Is that correct?
Okay.
That's right. The ratio of NOx to MMBTU value per hour will decrease.
But it's not just a matter of diluting out what you're now putting out.
No.
It's a matter that the number, the parts per million will actually go down if we use that number.
Translating it to that, yes. So the ratio again of NOx per burned MMBTU per hour will go down, yes.
Okay.
Do any other members of the board have any further questions of the petitioner? I thought we interrupted. No, I think they were done. No?
I'd like to go maybe walk you through the process a little bit myself and possibly Emily.
Yeah, please go ahead.
Okay.
Yeah.
In front of you, you should have a process flow diagram that simplifies the process flow, as we call it, of the gas and oil flow from the wells on platform Gina. It's off to the left of your diagram, and you can see there's some depictions there that are called production wells. There's actually 3 figures that are indicated. And we've also done some highlighting, and the highlight in yellow is what would be considered the current gas flow particularly from the wells that we're dealing with this amine and the tail gas and the CO2 production. You can see that the flow goes from the wells, and the last depiction of the wells is H1. It's called QAY. That's actually an API designation for a flowing well. H1 is the well that we're talking about. It's very small print. It's hard to read, but it's the bottom depiction of a well on the diagram. That production goes out and goes into what's called the MBD 601 gas scrubber. You can see that. And then out of that, and you can see the arrows basically designate the flow path, goes out of that scrubber and then up toward, and I'm just going directionally on the drawing here, up and then to the right, and it's called sour gas, going to MBF 104 sour gas scrubber. Prior to that flow from H1 going to that scrubber, we commingle, as we call it. We join the flow of what is produced off the other production wells on the line leading into that MBF 104 line, 104 scrubber. That line, I believe, Emily, is 2 inches. It's a 2-inch line. It's a very small line. It was an existing line, and we found when we commingled those 2 flows that we had quite a bit of back pressure. It didn't allow us to flow from our H1 well at the rates that we needed to, that 1.2 million that we'd like to get out of that well. And so that back pressure condition just forced us to cut back on the production from that well. It would then migrate commingled through the MAF 100 contactor, and that's to sweeten the gas. That's to take H2S out of the gas. And then from there it goes to what's called our chiller unit, which drops out liquids and water. And then from there migrates to our pipeline that goes to shore to the MOSF facility that Christine mentioned earlier. So before I go into what we'd like to propose, I'd just open it up to any questions on that flow.
Yes, sir. I have one question. Where was the bottleneck that you?
Yeah, the bottleneck. I mentioned that we commingle or join the flows of all the other wells on the platform with the flow from H1, and it's, unless I show you on the diagram, but if you follow the flow path of what comes out of H1 goes through the MBD 601 gas scrubber there at the bottom left of the drawing, and then off the top of that, the flow goes up and then to the left in the drawing, goes through a valve and then up, and then there's another line that comes in from the middle depiction of the production wells in the drawing, and it's joined at that point. That's our commingle point, at least depicted on this drawing. At that point is where we have that bottleneck, because we've got 2 inches of pipe diameter that we're trying to flow quite a bit of gas through, and it's just too much of a restriction.
I got it. Yeah.
That's our commingle point.
So instead of going from the gas scrubber back up to commingling with the stuff coming out of the production well, then going into the Oh, that's a production well. Anyway, where it meets there, right
Yes.
here. This is the problem.
That's correct.
Yeah.
Right there.
Right here.
So what we want to do is we want to say, well, let's just bypass that altogether, and why don't we take the H1 flow. Now I'm going to direct you to what's colored in red. So what we would do is take the flow directly off of H1, go through that MBD 601 gas scrubber again, and then back out of the 601 scrubber, and instead of going up and commingling with all the other production wells, we would bypass, and that's what the proposed change is depicted, that clouded line that bypasses essentially all of the other vessels and the commingle line or commingle point that we talked about, and goes directly to our pipeline, which operates at low pressure, and it would allow more free flow of that gas from H1 to our Mandalay facility. That line is designated to be 4 inches in diameter, and that would allow much more flow and freer flow to our Mandalay facility and allow us to flow that gas out of the H1 well.
So it would join that line coming out of the chiller
Correct.
at the bottom
Correct.
of your diagram?
Yes.
All right.
And allow more free flow, as I mentioned, and that would allow us to boost production of that H1 well, which then would allow the amine plant that we talked about at our Mandalay facility to now function at its design rate, produce more tail gas, which would then go into our flare.
Do any members of the board have further questions? I think Mr. Murphy was first.
The only question I have is, doesn't appear now under the proposal that you are going through something that takes the H2 out of it.
Thanks for pointing that out. I should have mentioned that if you look at the drawing, it has small clouds, if you will, that are called H2S scavenger injection. There's going to be 3 points of a chemical that's injected to actually extract H2S from the gas.
Yeah.
And it's done actually upstream of the MBD 601 gas scrubber, so that it's in a liquid form. It will adsorb the H2S and combine in solution with that chemical, and then be captured in that scrubber for processing as a separate liquid stream. So yes, we will take care of that.
Dr. Gerlach?
Yes.
Yeah, I have a couple of questions. This bottleneck you referred to, that dates to November of 2014, is that correct?
When we turn the H1 on, yes, that's correct, yes.
Okay.
And we were struggling at that point, sir, to try to increase production and see how it would actually react on the platform, and we realized that we were causing a severe back pressure condition on the production wells, and so we basically backed off on producing out of H1 because of that.
And the scrubber, what was the function of that previous to this change?
The MBD 601 gas scrubber?
Yes.
It was out of service until we put it back in service for the H1 well.
But what was it doing for the H1 well prior to the proposed change? Were you injecting a chemical into it?
Well, we were actually, the configuration was slightly different than what's depicted on this drawing. If you look to the right of the MBD 601 gas scrubber, we have what's called the iron sponges, and we used to direct flow through those iron sponges before using MBD 601. We used the iron sponges to extract H2S from the production off the production wells, but those sponges, the vessels actually deteriorated to the point that we had to take them out of service. So they're no longer in service. We've taken them out. In fact, we're in the process of actually taking them off the platform and just totally removing them.
So does this, does the proposed change, I'm not understanding, has the scrubber been inactive forever?
No, it hadn't. It had been used prior. I think we realized that there was a different flow scheme that was better suited to our processing requirements. We had taken it out of service and then put it back into service for the H1 well specifically.
Is it your belief or assertion that these changes, the red changes, can all be done without modifying your existing permit?
Yes.
Mr. Carmen?
Gentleman to the right, he has the same questions that I had, so I don't have any questions on that. Although, if you're going back into the draft of the interim variance, I have a question on that. And that is, do they put any time limits on those variances?
There were time limits that we had originally had on the draft, but however, they were beyond the date of this order. This order would only be good for 90 days, and there were some time limits and some limits that would have to be met. However, we didn't think it was, and maybe Robert could say something about this, but we didn't think it was appropriate to have dates on the order that were beyond the date that the order would actually be effective.
What staff is saying is that you have to have the hearing on the regular variance before any of those dates. So you have to grant that variance before any of those dates apply. They have to come into compliance before that, in which case you'd be updated or ask for that regular variance and then set the dates at that time.
Thank you.
Any further questions of the board to the petitioner? Mr. Hurlock?
Yeah, if the petitioner has finished presenting their case, I have a few questions I'd like to go through.
Please do.
Have you finished?
Yes.
To begin with, the permit, I was not exactly clear exactly which facilities. Does this cover GINA and the MOSF?
Well, where the flare is located is at MOSF or Mandalay, and that's permit 1017.
Right.
That's where the compliance issue exists. So that's what the variance is for. But what we've talking about platform GINA is a different air permit, separate, but there's no non-compliance on platform GINA. But these process flow changes we're making will occur on platform GINA, so that we'll have more gas going to Mandalay.
And those changes will be within the existing platform GINA permit?
Yes, this is only process piping changes. There's nothing to with any emission sourcing. It's closed piping, no emissions from it at all.
Okay. I'm looking through the draft. Do you folks have a copy of the draft order?
Yes, we do have a copy of the draft order, and all three of us have reviewed it, and we're okay with it.
I'm wondering if what the conditions were when the flare was tested in January in terms of.
Do you have a specific? I have the emission source test in front of me. Would you like me to?
Well, I made some numbers and I wanted to confirm it. It looks like it was running at maybe 21 or so, 65% of the 33 MMBTU per hour. I mean, MMBTU, yeah, per hour.
So I'm looking at the emission source test right now. It was done on January 20th, 2015, and our oxides of nitrogen pound per hour rate is 0.14 pound per hour, and that relates to pound per MMBTU of 0.0710, 0.07. The permit limit is 0.06.
I understand that. But you're permitted for 33 MMBTU per hour, and if I did things right, you weren't running. You had running at maybe 65% of that during this test.
Where's he looking?
Unless you cranked it all the way up to the 33.
Yes, sir. I believe we were running at lower MMBTU per hour at that time, yes.
Okay. So you do have the flare throttled back, but you, I originally thought that I understood this, but I'm wondering, I thought you were running, you were arguing that you're running too high, too hot. You're not running too hot, you're running at the 1400 degrees F is your lower limit by permit, is that?
That is correct.
Okay.
Yeah, so we've got a certain amount of fuel that has to go in there to keep the flare lit, to keep it burning. And that's why we put in the natural gas like you get out of your burner at home. That 30 MCFD has to go into the flare to keep it lit. And to that we add volume of tail gas. When the volume of tail gas is low, then there's more higher heating value gas, so therefore you get more NOx from that result. When you add more tail gas with the same amount of supplemental fuel or the PUC gas, you get lower NOx. And the way to get more tail gas into that flare is to get more produced gas from platform GINA to go into that gas treatment plant.
Are you running any air besides what is in the tail gas?
Are we what?
Are you running any air into the flare besides what comes along with the tail gas?
Yeah, this flare is what's called a low NOx flare, and it basically has louvers that open and close depending on the temperature of the combustion chamber. So if the temperature gets too hot, more air goes in. If the temperature gets too low, it closes down, and that actually happens all the time. But at the same time, we can't go below 1400 degrees Fahrenheit in the combustion chamber. The flare shuts down automatically because our air permit won't allow us to operate below that temperature.
Okay, I have a question relative to the previous test, which I assume was January of 2014 or thereabouts.
Mm-hmm.
Or do you have to test it every year or every 2 years?
Every 2 years is our testing cycle.
My question goes away then.
I think Emily may want to add something to that my testimony.
I was just going to clarify, there's no air in the gas going to the flare. You asked if there was more air, not in the gas being combusted, but by louver control, by the natural draft, that helps cool the flame temperature from the outside.
Is there any fuel or oxidizer at all in the tail gas? Does the tail gas contain any fuel or any oxidizer?
It may have a little tiny bit of fuel. The BTU content is probably in the 20 BTU for cubic feet, whereas natural gas, the kind that comes out of your burner at home, is in the 1,070 BTU per cubic feet. That's the difference.
So you basically just, I mean, what is being destroyed in the flare that comes out of the tail gas?
Well, most of the time, nothing if there's no hydrocarbon carryover from our treatment system. It's kind of a protective measure to make sure that there are no unburned hydrocarbons being emitted into the atmosphere. This is a secondary kind of treatment device.
And to further clarify, we're combusting CO2. We're getting rid of the CO2. That's the off gas from the main plant.
You run the CO2 through the flare, but I think it's inert with respect to the flare combustion. Is that not right?
Yes, it is. It is, and there's probably a small residual of some hydrocarbons that are in that.
So that's what you're destroying.
It's very minor, very minor. As Christine mentioned, it's probably in the heating value of 20, if that much.
But does your permit require you to run the flare?
Yeah, that's a
Yes.
Okay. You shut the amine plant down in November of two years ago, November 2013. And then in 2014, you made some more changes. Is H1 the only well that produces CO2 in the produced gas?
The majority of our CO2 is produced from that H1 well, yes.
Is the CO2 in the rest of the gas low enough that you can sell
There
it?
is, I say majority because there is some small residual that occurs with produced gas, solution gas that comes from the other operations that are taken care of at our Mandalay facility.
Taken care of how?
Off gas, there's oil that's produced at Mandalay, or processed at Mandalay, I should say, produced from our platforms. And there is solution gas that comes off that oil. And that gas is processed within the Mandalay facility. And I would suspect that we have a little bit of CO2 in that gas as well.
Do you not sell that gas?
It's mixed in with our processed gas and processed for sale, yes.
Without taking the CO2 out?
We do. No, we would run it through our amine plant.
But the amine plant was shut down for a year and a half. That was my question.
It becomes a real problem if we don't have the amine plant running.
But you ran for a year and a half without it.
And it caused us to run our process to mix that gas with our sales gas at a very prescribed rate so that we could sell it and be within specification.
I have a suggestion to kind of clarify, at least in my mind, the text, and this is, if you agree with this, I'd recommend it to the district staff. On the very bottom of page 3, there's a sentence that says, large pressure losses occurring through the 2-inch pipeline after combining gas from well H1 and so forth. Would it be incorrect to add after combining high pressure gas from the well H1?
Yes, H1 is produced at a lower pressure because currently we are mixing it with the rest of the gas and running it through a sweetening system. It all has to be produced at a lower pressure, which is 35 to 40 psig. So because they commingle and run through the same system, we cannot produce H1 at a higher pressure to combine the gas streams.
Okay. Thank you. There's a section that I'm not sure who drafted it, but I don't understand it at all on page 6. There's a paragraph in which there's one sentence. And the paragraph says, if the flare cannot be operated DCOR, if that's something that you can explain to me, if not, I'll ask the district staff. I just don't understand that whole sentence. Or page 6 in the paragraph that is about in the middle of the page under item 2 that says, if the flare cannot be operated, DCOR would need to shut in all platform Gina well H1 gas production and have to cease all oil and gas production at platforms Gina and Gilda due to inability to treat gas breaking out in the heater treater vessels located at the MOSF. I just don't understand some of the words and how they go together, what they mean.
Well, if I could simplify it somewhat, the H1 well is highly dependent on the amine plant and, of course, the flare to deal with that tail gas. So if we don't have the flare, we essentially can't run the amine plant because we don't have a way to dispose of that tail gas. On top of that, and as I mentioned to you too, we produce the oil from the platforms, and it's processed at our Mandalay facility. That's the MOSF. Those facilities then have solution gas that we have to deal with as well, and part of the processing mix that we deal with at Mandalay facility, the MOSF, is to process that solution gas, which has a little bit of CO2, and we've got to deal with it as well. So it would harm us in the long term if we had to shut down that flare and shut down that system. It would, in the long term, hurt us not only on GINA H1, but GINA oil production, and ultimately Gilda oil and gas production.
But
We can survive on a short-term basis, but not really on a long-term basis.
But for the time that it would take you to make the changes, including the 90 days of this requested variance, couldn't you just shut in well H1 and bypass the amine plant like you did for about a year and a half in 2013-14?
Well, we could, but it was extremely difficult to operate. And the other factor is that we've actually increased our production off of platform Gilda, which has introduced more gas and more production to deal with it at our Mandalay facility. So it's a little bit different scenario now operating than it was back a year and a half ago.
So you can no longer operate the way you did from November.
It would be very
June.
difficult.
Is that different from you can't do it?
It would be very difficult. I would say that it would probably cause us to curtail some production in order to make it work.
Have you already begun on the fabrication and construction that was going to start on March 16th?
We have, yes. In fact, we're in the process. We've already done, as we call it, our layouts of the piping scheme, the identification of the tie-in points. We've actually started fabrication of the piping spool that we describe in our bypass loop. And we've actually ordered equipment that would allow us to inject the chemical that we talked about to sweeten the gas or to extract the H2S from that gas. So all that's already been done.
Is that chemical proprietary, or can you tell the board what it is?
It's proprietary to the chemical company that we buy it from. They have a trade name for it, but you'd have to ask them what it's made of.
Do any other members of the board have any further questions of the petitioner at this time? Do any members of the board have any questions? Does the district want to say anything, weigh in on this at this point?
Well, I think this problem is complicated by the fact that H1 was down for what, probably a year and a half, and maybe that's why they were able to not have to run the amine plant. I'm not sure how that timing is in there, but it's my understanding that gas from H1 used to come to shore via the oil pipeline, and H1 went down. It was down for more than a year at least, and when it came back online, in the meantime, there was a federal regulation that talked about monitoring oil lines that had changed, and that basically meant that DECOR could no longer send gas from H1 to MOSF through the oil pipeline. It had to be combined with gas from the other wells. So there was a regulation change that was kind of in the middle of all this too, and that's it seems to me like everything kind of came together in the perfect storm at the wrong time. But that's the way that I understand the problem. I don't think if they could still send the gas to MOSF through the oil pipeline, I don't think we would even be sitting here today.
Excuse me, you don't what? If they can still send it, I didn't hear your last sentence.
If they were allowed to, if the federal regulations hadn't kicked in for the oil pipeline that basically requires, there's monitoring that they're required to do now for the oil pipeline, and having gas in the oil pipeline makes it impossible to do that monitoring. So if that regulation hadn't changed, then they could probably still send the gas from H1 on shore via the oil pipeline. But since that changed, and I believe that changed while H1 was down. So I think that kind of adds to the problem. It's kind of confusing, but we've talked quite a bit about the problem and how it happened, and there are a number of things now that are different than were back before H1 had the problems, and that's why we believe that there was no way to really foresee that there's a problem. They just had to do the test, and then it turned out that not enough tail gas, so that the heating value of the gas burned in the flare is too hot. And one of the ways that you control NOx is to lower the flame temperature. So if you add more of the tail gas to the gas burned in the flare, then that would effectively lower the flare temperature, but it would still meet the 1400.
I have a general question.
Yeah, we'll get okay. You want to ask the staff a question?
To staff, yes. These laws from the federal government, are they all retroactive, or, sometimes they have grandfather law that if you were doing this way, it's from now on, but you say that it goes to back to a producer that was doing it years and years ago?
I don't know if they're retroactive or not, but it's my understanding is that DECOR has to comply with this regulation, so that makes it impossible to send the gas from H1 to shore through the oil line. Now it has to go through the gas line. So there's this bottleneck that we had didn't used to be a problem because gas from H1 didn't used to be mixed with the gas from the other wells. So and what they essentially want to do is they have a 2-inch line. They want to go around the 2-inch line, and then where there's a 4-inch line, that'll be where they will mix the gas. And so then it shouldn't be a problem. And the problem with having the bottleneck from the way that I've been told is that it creates a lot of back pressure on the wells, and anytime that you have oil wells and there's too much pressure on the wells, then that tends to also inhibit oil production.
Thank you.
Do any other members of the board have questions for the district?
Yes. This goes to the form of the draft order a little bit for interim variances. And because the only requirement that we have for an interim variance is that it may be granted for good causes stated in the order granting such a variance. But we do, as a matter of form, actually set forth all the findings of fact required by Section 42352, simply because we'll get to those eventually, and it also goes to the fact of whether there is good cause. However, I do not find that, even though there is one section that is headed good cause, on page 5, the facts giving rise to good cause are not all contained in that particular one section, and there really is no finding or conclusion contained in the order itself of us determining that there is good cause. And I was wondering then if we might insert, here as a suggestion then, on the conclusions and order that's on page 8, start there, now therefore the hearing board, and insert, finds and concludes that good cause has been shown, and then continue on, orders that dos quadros, etc. Then also then, because this is an interim variance, again, we've talked to the fact that there is no final compliance dates or anything like we would have in a normal variance. It seems like on page 9 of the order that sections B, 3, 4, and 5 are really inappropriate because they talk about final compliance dates, and there's no final compliance dates when we're dealing with an interim variance. So I would you agree that those 3 should be deleted?
Yes.
I have nothing further.
I think those would show up in order number 857, which we have not met on yet.
Yes.
Thank you, Mr. Murphy. Mr. Hurlock?
Yes, I have a couple of questions. One, I wanted to comment on Mr. Murphy's. I had the same question relative to these the 6 or 8 findings, and I looked at the book, and there is the good cause under 42-351, but under 42-352 it says findings prerequisite to grant a variance. No variance shall be granted unless the hearing board makes all of the following findings.
But I think that is, I'll ask our attorney, Mr. Oriano, that in 42352 refers to a regular and not an interim variance. Would that be correct?
That's correct, with one caveat. If you know there's a likelihood that they could not meet those, you can't find good cause. And I think that's why they're examined. There has to be a likelihood that they can meet the requirements for a regular variance before you can say you found good cause.
So no variance shall be granted doesn't mean no interim variance shall be granted?
Right, that's right, because the more specific statute controls for the interim variance.
You lawyers. I have another
We don't draft the codes.
Mr. Hurlock?
Yes, I had a
Legislatures do.
a question for the district, and this is the question I was concerned that might need a little research or consulting with engineering. I asked the petitioner, and they're of the opinion that no changes in permits, either for MSOF or Gale, is it Gale, would be required by the proposed changes. I don't think there are really any changes at MOSF, but there's some pretty significant changes on platform Gale. Has the district had a chance to look and see whether that those changes, they have any issues about those needing a change in the permit?
I wouldn't anticipate any changes. We're really talking about a piping change, and we're talking about a couple of injection points, and that's not something that our permits would not normally specify that.
Thank you.
Any further questions from the board for the district? Does the district have anything else to say on this? Okay.
I wanted to look a little bit more carefully about what Mr. Murphy was talking about on page 8 or 9. If we simply strike items 3, 4, and 5, does that take out anything about them needing to, is that consistent with everything else? I mean, the main point is they need to be back here in 90 days. Is there something in here that indicates that these reports will continue until that happens, or should there be?
Mr. Searcy, what say you?
I'm sorry, your question is there anything in the draft order that requires that they continue reporting? Was that
what
your
I'm really asking, in a little more general than that, if we strike 3, 4, and 5 on page 9, does that leave something hanging? And perhaps it just says monthly progress reports. The thing is that these monthly progress reports are the requirements for this variance, not for the regular variance.
Right.
So I'm just wanted to make sure that there's nothing left hanging about the end of this variance and the period at which these requirements are met.
I don't believe we would leave anything hanging. The only, these monthly progress reports would also be in the regular variance as well as a number of dates that they have to meet. When we originally wrote this, we actually had the dates for the increments of progress, and then we looked at them and we said, wait a minute, these dates are past the date of this order, so we need to pull them out. But everything that's in this order will also be in the regular order, plus a number of dates that aren't here now.
Thank you.
Okay. Do any members of the public wish to offer testimony tonight? Okay. Board comments.
I would like to ask Mr. Murphy, if I could, he had made a suggestion for page 8, and maybe if he could repeat that for us so we could get it.
Insert
Sorry.
after the word board and before the word orders, finds and concludes that good cause has been shown and.
Where are you?
Pardon?
Where are you on page 8?
On the bottom paragraph. Start at the bottom. Now therefore, the hearing board, after the word board, inserts finds and concludes that good cause has been shown and then continues, orders, etc.
Okay, thank you. Did you get that?
Do any other members of the board wish to make any changes? Okay, hearing no further suggestions for changes, clerk of the board, take a vote.
Don't you have to close the hearing?
The hearing is closed.
Oh, you need a motion.
Yeah, I need a motion going on.
Need a motion?
You want me to make?
Yeah, go ahead.
I move that with the suggested amendments that have been made and taken down, that we approve the draft order granting the interim variance.
I'll second Mr. Murphy's motion. Okay, Mr. Carmen?
Yeah, I second too.
Mr. Herlock? Or, oh, you're,
Board Member Bonsbach?
Yes.
Board Member Murphy?
Yes.
Board Member Stubblefield?
yes.
Board Member Herlock?
Yes.
And Board Member Carmen?
Yes.
Motion carries 5-0. Your interim variance has been granted with those modifications. Thank you.